Hello everyone, welcome back to another video. Today we're going to be building a machine learning model that can accurately classify images of different dog breeds. Now before we get into the video, if you guys want to see more videos like this, drop a like down below. It helps us out tremendously with the YouTube algorithm, and with that out the way, let's hop right into it. Alright, so in this project we'll be using the CFAR10 dataset, a collection of labeled images available in Scikit-Learn's datasets module. Let's begin by importing the necessary libraries. Right, so we first import NumPy for numerical operations and the necessary components from Scikit-Learn. Specifically, we'll be using the fetch OpenML function from the datasets to load our images dataset. Additionally, we import train test split to split the data into training and testing sets, and kneighbors classifier as our classification algorithm, and accuracy score to evaluate the model's performance. Now let's go ahead and load our dog breed dataset. So here we call the fetch OpenML function to fetch the CFAR10 dataset. The images of different dog breeds are stored in the data variable, and the corresponding target labels are stored in the target variable. Next, once it's done loading, we'll split our data into training and testing sets. And we're still waiting for this to load because the images from this dataset take a really long time to load. But using the train test split, we split our data into training and testing sets, and then here we allocate 20% of the data for testing, while the remaining 80% is used for training. The random state parameter ensures the reproducibility of the split. Now let's build our dog breed classification model. For this project, we'll be using the k-nearest neighbors algorithm. Right, so here we initialize a k-neighbors classifier object as our model. K-nearest neighbors, or KNN, is a popular algorithm for image classification tasks. We then train the model using the fit method, passing in the training features xtrain and the target label ytrain. Now, with our model trained, we can go ahead and make predictions on the test set and evaluate its performance. We use the train model to make predictions on the test set using the predict method. The predicted labels are stored in the predictions variable, and then to evaluate the performance of our model, we compare the predicted labels with the true labels from the test set and calculate the accuracy using the accuracy score function. And then the last thing we'd have to do is just print out the accuracy. You could just do like that. Alright, and there we go. We have just successfully built an image classification model using the Scikit-Learn library. we trained the model, evaluated its accuracy, and if you guys are doing this on the desktop or you're copying along, you can wait a little longer for the images to load. It would take a really long time here, so I'm not going to wait for that. But yeah, if you guys enjoyed or found this helpful, drop a like down below, drop a comment, and we'll catch you in the next one.